All right, guys, we're going to move along to lesson 8.2. So let me present my screen so we can start. All right, we actually already defined both of these terms in lesson 8.1, but I will just present them another time so you can jot them down into your notes. The more we view the terminology, the more familiar we become with it. Okay, so similar figures to start. All right, so again, similar figures, geometric figures that have the same shape, but not necessarily the same size. Pause the video if you need to have an extra second to copy that down to your notes. Next is similarity transformations, which again, we already defined as well, but I want to review it one more time. A dilation or composition of rigid motions and a dilation. So a dilation is the one transformation that we've studied that changes the size of the shape. So it produces a similar figure. Okay, so that was it for vocabulary for lesson 8.2. All right, just as a quick recap before we move on to proving triangles similar by AA, what we learned, ignore that, what we learned in lesson 8.1 is that if you are given triangle ABC is similar to triangle DEF, okay, if we're given that information, then we know that all corresponding angles are congruent. So we could say that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. All right, and then we know the sides, there's my little bullet, there we go, sides are proportional. Sorry, that's so messy. So we can say that side DE corresponds to side AB and is equal to side EF, which corresponds to side BC, which is equal to side DF, which corresponds to side AC. And they're all equal to K, that scale factor. Remember, K is your scale factor. All right. So that is what we learned in lesson 8.1. In lesson 8.1, we were told the triangles were similar. Now in this lesson, we're going to talk about, well, what if you're not told the triangles are similar? What do we need to know in order to prove that the triangles are similar so then we can say all those corresponding sides are proportional and angles are congruent? Okay, so we have this theorem called the angle-angle similarity theorem. And this theorem states that if two angles of one triangle are congruent to two angles of another triangle, that's enough information to say that the triangles are similar. So here I have angle A is congruent to angle D, and angle B is congruent to angle E. With that information, I'm allowed to now say that triangle ABC is similar to triangle DEF by AA similarity. Okay, so for example 1, it says, determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. All right, so the triangles are not oriented the same way, right? I have my 90-degree angle here, my 90-degree angle there. If it's helpful, you may want to sketch the two triangles so that they are oriented the same way on the paper. Sometimes it's helpful for students and for naming purposes. All right, so I have my 90-degree and C is my 26-degree angle. Now, before I go any further, I want to figure out what the missing angle measurements are. So I know that the measurement of angle E is going to equal 180 minus 90 minus 26, right? Because the three angles have to add up to 180. So angle E is going to equal 64. And I also know that the measurement of angle K, right, that angle there, is equal to 180 minus 90 minus 64. And when I do that subtraction, I have 26. So I know I can label this angle 26 and this angle 64. I actually have more information than I need to state that the two triangles are similar, right? I have this angle congruent to this one. I have this angle congruent to this one. That's enough. Two angles of one congruent to two angles of another. That's enough to state that the two triangles are similar. But I actually have the third angles, right? The 90-degree angles, they were given. All right, so I can say triangle, and make sure you name them correctly. So triangle DEC, so DEC is similar to triangle GHK by angle similarity. Okay. Now I have my work over here, so that's sufficient for my explanation, or you can write, how you came up with those angle measurements. That's fine. One thing I do want to say is the way you and I name our triangles might be different. Okay. I could say triangle EDC is similar to triangle HGK by AA, right? There's multiple ways, but you have to make sure that corresponding parts match up when you're stating the similar triangles. It's the same as what we had to do with congruent triangles. So that shouldn't really be new information or something challenging for you. Okay. All right. Example 2, show that the triangles are similar. All right, here, show that they want us to show that the triangles are similar, but they're stating the names of the triangles, so we know exactly which triangles to look at and what parts are supposed to match up. So triangle ABE, so that's small triangle. Again, if you find it helpful, you might want to resketch it. All right, so this triangle here, which there's a 52-degree angle there, and then also triangle ACD. A, C, D, and I have a 52-degree angle there. Okay, so are the two triangles similar? I have this angle is congruent to this. Anything else? Wasn't angle A congruent to itself, reflexive property? Right? So I could say the measurement of angle A is congruent to the measurement of angle A, reflexive. And then you're given that the measurement of angle ABE is congruent. Oop, I shouldn't be putting the measures. Not paying attention to my notation. I shouldn't have the M's there. Pretend this M's not there. All right, angle ABE is congruent to angle ACD. That was given. That was marked. Okay, so therefore I know that triangle, and I'm going to name it ABE. Oh, they named it for us up here, I guess. ABE is similar to triangle ACD by AA similarity. Okay. Now, before we move on from this problem, I do want to just explain one other thing, but let me erase everything I had so far. Aren't these two angles corresponding angles? Right? So wouldn't these two lines be parallel to each other? And if those two lines are parallel, isn't this angle congruent and corresponding to that one? So I could have used those angle pairs as well. I'm just pointing that out because that's something else that you might have to look for in other problems. I didn't use that information for this problem to prove that they're similar, but I could have. Okay. All right, the next problem. I want to prove that triangle SVR is similar to triangle UVT. I could start, I don't have to, but I could start by marking my vertical angles, right? Angle SVR is congruent to angle UVT, and they're vertical angles. That's why. And then parallel lines cut by transversal. I could name these two angles congruent. They're alternate interior. I could also name the other ones, S and U, but I don't need all of them. I just need two angles congruent to two angles. So I can say angle R is congruent to angle T. And how do I know that? I know that parallel lines imply alternate interior angles congruent. Again, I can mark S and U, but I don't need it. Maybe instead of using the vertical angles, I just use the two pairs of alternate. It's up to you. Okay, but now I can say that triangle SVR is similar to triangle UVT by AA angle similarity. Okay. All right. Move down. All right, example 3. It says a flag pole casts a shadow that is 50 feet long. Okay, so here's my flag. Here's the shadow. I know I'm looking at a triangle because these are all triangle problems, really. All right, so there's my triangle, and the shadow is 50 feet long. It says at the same time, a woman standing nearby who is 5 feet 4 inches tall. So here's my lady. She's 5'4". It's about my height. So 5 feet 4 inches. All right. She casts a shadow that's 40 inches long. Okay. How tall is the flagpole to the nearest foot? Okay, so we want to know X. Well, hopefully you look at this and you're like, oh, I just set up a proportion. And you do. Okay, you're going to set up a proportion to solve for this. All right, so in order to set up a proportion, though, you need everything to be in the same units, right? You can't have 5 feet 4 inches over 40 inches equals 50 feet. Like you can't have a bunch of different units. So I need to convert everything into inches. Okay, so 50 feet into inches, you're going to do 50 times 12, and you're going to get, what would that be? 600 inches. Okay. And then 5 feet 4 inches. Well, 5 feet, 5 times 12, it's 60 plus 4, that's 64 inches. So now I can say the height of the lady is 64 inches over the height of the flagpole unknown is equal to the shadow of the lady, 40 inches, over the shadow of the flagpole, which is 600 inches. I could have also done 64 over 40 equals X over 600. Okay, it's up to you. This is one way of setting up the proportion. There are other equivalent ways. So if you set it up differently, do the math because you'll still get the same answer as me, most likely, if you set up an equivalent proportion. So cross products, I'm going to multiply 40 times X to get 40X, and I'm going to multiply 64 times 600 to get 38,400. And then I'm going to divide both sides by 40, and you get X is equal to 960 inches. Remember, everything is in inches right now. But we want to know to nearest foot. So how do I go from inches to feet? Well, now I have to divide by 12. So 960 divided by 12 gives you 80 feet. Okay, so this flagpole is 80 feet tall. All right. All right, guys, that is it for lesson, what was that, 8.2? I think 8.2. Yeah. All right, so I'll see you back here for lesson 8.3. Bye.